Welcome to Supermatics, your number one top channel where we bring you top-notch maths tutorials. Today we bring you 4 exciting exponential equations, so fasten your seatbelt and join the ride. Here is the first equation.
To solve this exponential equation, we start from the left-hand side by writing 6 to the power of x as 2 times 3, then all to the power of x minus 4 times 3 to the power of x, and the right-hand side remains 3 times 2 to the power of x minus 12. Now, 2 times 3 all to the power of x can be written as 2 to the power of x times 3 to the power of x. This is because from the law of exponents and powers, if we have a times b to the power of m, it can be expressed or written as a to the power of m multiplying b to the power of m. So having expressed that in that form, then we have minus 4 times 3 to the power of x, completing the left hand side, then equals 3 times 2 to the power of x minus 12. Now, considering the left hand side of the equation, 3 to the power of x is common, so it can be factored out. We factor it out, 3 to the power of x, then we'll be left with 2 to the power of x minus 4 in parentheses. Then, the right hand side, we can factor 3. So when we factor 3, we'll be left in parentheses with 2 to the power of x. This, when we factor 3 from 12, we're going to be left with 4. Now, I know at this stage, you might be thinking of cancelling out 2 to the power of x minus 4. That would be a very great mistake in mathematical terms, and especially with the peculiarity of this equation. So the best thing we try to do is bring this one into this side. We subtract it from both sides, so that equation becomes 3 to the power of x, then times 2 to the power of x minus 4 in brackets, minus 3 times 2 to the power of x minus 4 in brackets, and that equals to 0. So with that done, 2 to the power of x, 2 raised to the power x minus 4 is common to both expressions or both terms that we have on the left hand side. You can take it out, and after taking it out, we have 3 to the power of x minus 3 left. So this factors as 3 to the power of x minus 3, then multiplying 2 to the power of x minus 4 equals to 0. And when we have a product being equal to 0, it's either the first one is 0, 3 to the power of x minus 3 is 0, or 2 to the power of x minus 4 is 0. Now, if 3 to the power of x minus 3 is 0, it means that 3 to the power of x is 3 when we add 3 to both sides, or 2 to the power of x is 4 when we have 4 to both sides with the second root. Now, we are going to break this down into 2, taking them one by one so that we can check the validity of the results. So starting with the first one, let's call it case 1. And that one is 3 to the power of x equals to 3, which can be expressed as 3 to the power of x equals to 3 to the power of 1. So when we equate the indices, x is going to be 1 as the bases are equal. Now, before we proceed, let us test this with the original equation. So let's do a little check. We run a little check to test the validity of x equals to 1. Now, the original equation is 6 to the power of x minus 4 times 3 raised to the power x. So we start with the left-hand side. Well, in our check, the left-hand side becomes 6 to the power of 1 minus 4 multiplying 3 to the power of 1. And this is going to be 6 to the power of 1 is 6, and minus 4 times 3 to the power of 1 is 3, so that's minus 12. 4 times 3 is 12, giving us negative 6. Now, the right-hand side. The right-hand side is 3 times 2 to the power of x, so that's 2 to the power of 1 and minus 12. Now 3 times 2 to the power of 1 is 6, so 6 minus 12 is also negative 6. So in this case, the left hand side is the same thing as the right hand side, meaning that x equals to 1 is valid. It's an answer. It's a solution to the equation. Now we go for the second case, which is when 2 to the power of x is 4. So 2 to the power of x is 4 implies that 2 to the power of x is 2 to the power of 2. Now the bases are the same, so we equate the exponents. X equals to 2. Now we are running another check with this to determine whether it's also valid. Now the left hand side, as we did earlier on, will become 6 to the power of 2 minus 4 times 3 to the power of 2. 6 to the power of 2 is 36, and 3 to the power of 2 is 9, so 4 times 9 is 36. 36 minus 36 gives 0. The right hand side is 3 times 2 to the power of x, so 2 to the power of 2 and minus 12. So 2 to the power of 2 is 4, so raised to the power of 2 is 4, times 3 is 12, so we have 12 minus 12, which is also 0, meaning the left hand side here is also equal to the right hand side, and it means x equals to 2 is equally valid. Now we can say that the solution to the equation, or the solution set, so the solution set to this exponential equation is 1 and 2, two values.
The second equation.
To solve this beautiful exponential equation, we are going to express 4 to the power of 2 over x as 4 to the power of 2, then to the power of 1 over x. And that plus 4 equals to 5 times 4 to the power of 1 over x. Then we can swap the exponents here. We can swap the exponents to give us 4 raised to power 1 over x all squared, and plus 4 equals to 5 multiplying 4 to the power of 1 over x. So what we do here is transformation. We make a representation for 4 to the power of 1 over x. So we can say let 4 to the power of 1 over x be t. So we're going to use t to transform the equation to something solvable before we now go back to the original variable, which is x. Now, if this is t, 4 to the power of 1 over x, 4 raised to power 1 over x raised to power 2 becomes t squared when we substitute, and that's plus 4 equals to 5 times t on the right hand side. Then we can rearrange the resulting quadratic equation to have t squared. When this comes to this side, we have minus 5t, then plus 4 equals to 0. Now we're going to factor this trinomial, this quadratic equation that we have, by looking at the factors of plus 4, whose sum will give us negative 5, and those should be minus 1 and minus 4. So using minus 1 and minus 4 to factor this, it is going to factor as t minus 1 multiplying t minus 4, and that's equal to 0. So from here, t minus 1 is either 0, or t minus 1 is 0, or t minus 4 is 0. So if t minus 1 is 0, then definitely t is 1. Now, if t minus 4 is 0, t is going to be 4. Now, we are going to need these values in order to know the exact value of x by putting them back into this expression, this transformation we made earlier on. Now, we take them one by one. So we start with when t is 1. Now, when t is 1, we put in 1. That gives 4 raised to power 1 over x equals to 1. And 1 can be expressed as 4 raised to power 0. So we have 4 raised to power 1 over x to be 4 raised to power 0. Meaning that if we equate the indices, the exponents, we're going to have 1 over x equals to 0. This is not possible, because when we try to cross multiply, x is going to vanish completely. So it is undefined, which means that this is not a solution. Then we check the second one when t is 4. So when t is 4, we put that one also into 4 raised to power 1 over x, and that's equals to t, which is equal to 4. 4 can be written as 4 raised to power 1, so we have 4 raised to power 1 over x to be equal to 4 raised to power 1. And when we equate the exponents, the powers are the same, so we can drop them. The bases are the same, so we can drop them. 1 over x is 1. And taking the reciprocal of both sides, x will be found to be 1. We can check the result by placing the value in the original equation to see that it is valid. So we can say, therefore, x equals to 1 is the only real solution to the given equation.
Here is the third equation.
To solve this yet another beautiful exponential equation, which is 9 raised to power x plus 6 raised to power x equals to 2 times 4 raised to power x, we're going to be needing to divide both sides by 4 raised to power x. So divide both sides, or divide through by 4 raised to power x. So when we do so, we're going to have 9 raised to power x over 4 raised to power x, then plus 6 raised to power x over 4 raised to power x on the left hand side, and on the right hand side we have 2 times 4 raised to power x, then over 4 raised to power x, so that on the right hand side 4 raised to power x we cancel out. Now 9 raised to power x over 4 raised to power x can be written as 9 over 4 all raised to power x. Then 6 raised to power x over 4 raised to power x can be written in like manner as 6 over 4 raised to power x, and that will be equal to 2 on the right hand side. Now this is in compliance with one of the laws of exponents. You recall that if we have x raised to power a over y raised to power a, when the exponents are the same, we can express them as x over y to the power of a. That is what we used here in both cases. Now 9 over 4, 9 can be written as a square of 3, while 4 can also be written as a square of 2. So we have 3 squared over 2 squared all to the power of x. Then plus 6 over 4 can be reduced to the lowest term, which is 3 over 2. Then that to the power of x. We can bring in 2 to this side, so it becomes minus 2 and equals to 0. Now 3 raised to power 2 and over 2 raised to power 2 can be expressed just the same way we did earlier on, and the power will come here. So we can have it as 3 over 2 all squared and everything to the power of x, then plus 3 over 2 raised to the power of x minus 2 equals to 0. Now we can swap the powers, the exponents. We can swap the exponents that we have here and express it as 3 over 2 to the power of x raised to power x all raised to power 2 by swapping the exponents, then plus 3 over 2 raised to power x minus 2 equals to 0. So that we can now do a kind of transformation whereby we let 3 over 2 to the power of x be a particular variable, another variable to represent that. So let 3 over 2 to the power of x be, say, p, so that our expression, our equation becomes p squared plus p minus 2 equals to 0. Then we factor the resulting quadratic equation, and factors of minus 2 that will give us plus 1. The middle term is, these factors are minus 1 and plus 2. So these factors are p minus 1 times p plus 2 equals to 0. And if this product is 0, it's either p minus 1 is 0 or p plus 2 is 0. So if p minus 1 is 0, that can only mean that p is 1. Then p plus 2 is 0 can only mean that p is negative 2. Now, we need to go back to the original variable, which is x, by going back to our transformation right from here. So when p is 1, we put in 1 into that equation. 3 over 2 raised to power x equals to 1. And if that is 1, we have that 1 can be written as, this implies that 3 over 2 raised to power x can be written as 3 over 2 raised to power 1, raised to power 0 rather. Any number to the power of 0, any number carrying exponent 0 gives 1. So therefore, the bases are now equal. We can say x is 0. That's the first case. we can call that case 1. Now, the second case is the other answer, and that is when p is negative 2. So when p is negative 2, if we put it in a transformation which we made earlier on, 3 over 2 to the power of x will be equal to negative 2. Now, this solution is not valid. Even if we take the logarithm of both sides, negative 2 minus 2 is not in the domain of logarithm. Even if we take the logarithm of both sides. So that renders the negative 2 invalid. So this is not a solution. Not a solution. And as such, this is not a solution, and as such, it's simply, the only thing it means is that x equals to 0 is the solution. And this solution can be checked by putting 0 here. 9 to the power of 0, 9 raised to the power 0 is 1, 6 raised to the power 0 is 1, so 1 plus 1 gives 2. Then 4 raised to the power 0 is 1, 2 times 1 gives 2. That's the only valid solution.
Now on to the last exponential equation.
To solve this beautiful exponential equation, we are going to be writing 10 to the power of x as 2 times 5 all to the power of x. So the equation becomes 5 to the power of x raised to the power x minus 1 equals to, in brackets, 2 times 5 raised to the power x, then times 2 raised to the power negative x times 5 raised to the power x plus 1. Now we can distribute the exponents based on one of the laws of exponents and power, so that the equation becomes 5 raised to the power x minus 1 equals to 2 raised to the power x times 5 raised to the power x. Then this one can be written as the reciprocal of 2 raised to the power x in accordance to yet another law of exponents and power, then times 5 raised to the power x plus 1. So that from here it can be seen that 2 raised to the power of x on the right hand side cuts this in the denominator, so that the equation becomes 5 raised to the power x minus 1 equals to 5 raised to the power x times 5 raised to the power x plus 1. Now, from yet another law of exponents and power, we have products here of the same base. So we are going to add the powers to the exponents together. We're going to add the exponents together so that we have 5 raised to the power x minus 1 will be equal to 5 raised to the power x plus this other one, x plus 1. So that we have 5 raised to the power x minus 1 equals to 5 raised to the power x plus x gives 2x, then plus 1. Now that the bases are equal, which is 5 on both sides, we can drop them and equate the exponents. So we equate the exponents. When we equate the exponents, x minus 1 is going to give us 2x plus 1. Then we can subtract 2x from both sides and add 1 to both sides at the same time, so that on the left hand side we have x minus 2x, and on the right hand side we have 1 plus 1 when this moves to the other side. So x minus 2x is minus x, and 1 plus 1 is 2. Then multiplying both sides by negative 1. Then we multiply by negative 1. We are going to have negative 1 times negative x, and then negative 1 times 2. So that x is negative 2. If we put x is negative 2 on the left hand side, we're going to be having something like 1 over 125. Try it on the right hand side and see that we have the same results. Thank you for watching the videos. Please subscribe.
Solve this and comment with your answer, or send it to the email given in the description below. Thank you for watching the video. Kindly subscribe and hit the notification bell to get more updates. Bye.